Assalamualaikum and hello everyone. In this video, what we're going to learn is actually the condensation of your carbonyl compound with ammonia derivative as identification test for carbonyl compound. So let's look on your notes on page 6. So the condensation with ammonia derivatives ni apa maksud dia? Okay, so actually yang from compound number 1 until number 5 ni, all of it is ammonia derivative. So maknanya originally semuanya pada NH3. Tapi what happen adalah one of the hydrogen is being replaced. So contohnya dalam kes ni dia jadi ada metal, ada yang dengan OH, ada yang dengan another of our NH2. So macam tu lah. Okay, so what is this reaction is that for the condensation, it means that the two molecules combine to form a larger molecule with the elimination of smaller molecule. So dalam kes ni, what we're gonna condense, so we're going to remove is actually H2O. H2 is from two of our hydrogen from our ammonia derivative, oxygen tu from our carbonyl. Okay, so let's look here. First adalah ammonia. So ammonia is N and bonded to 3 of our hydrogen. So what we're going to remove oxygen here dengan 2 of our hydrogen. So what is left is our, yang ini kita maintainkan double bond. Oxygen dah tak nak tulis. Lepas tu hydrogen pun tak nak tulis. Directly bonded to our nitrogen. Okay, and then nitrogen ni, what is left is that hydrogen 2 ni tak nak. What is left is only one of the hydrogen. So that is the product. So yang H plus ni is used for the condensation reaction, memang kena ada lah. Okay, so again nitrogen ni memang nak 3 bond saja sebab ada satu lone pair. Okay, how about this one? So sama juga, we're gonna remove oxygen. Okay, and then we're gonna remove 2 of our hydrogen. So copy paste je. Maksud dia salin balik sajalah. So nitrogen dekat sini, lepas tu nitrogen is bonded to hydrogen. Okay, so nak tulis plus H2O, nak ke tak nak pun it's fine, up to you. Since this is a byproduct, so it's not compulsory for you. Okay, so now let's look for the case of amine. So kalau amine pula, apa beza dia? Nitrogen ni bonded to 2 hydrogen, satu tu must be alkyl group. So dalam case ni, both of the cases I use CH3. Tapi boleh juga kita punya ethyl, propyl, semua benda boleh. So what we're gonna do, remove our O dengan hydrogen. Tapi in this case, nitrogen tu is not bonded to hydrogen dah, dia bonded to our CH3. So tulislah CH3. So kalau B pun sama juga. We're gonna remove O kat sini. We're gonna remove hydrogen as well. So what is left is actually our CH3. Okay, so that's for case of amine. Sekarang ni hydroxylamine. Hydroxylamine ni adalah NH2 dengan OH. Dua-dua dia ada. Make up your mind, tak nak dia nak dua-dua. So what we're gonna remove adalah we're gonna remove our hydrogen dengan OH, dengan hydrogen dengan oxygen. So what is left? Maknanya substituent of N2 sekarang ni dia attached to our hydrogen. Hydrogen OH. The same goes here. Nitrogen attached to our OH once we remove our H2O. Okay, so that's for hydroxylamine. So next tengok hydrazine. Hydrazine ni pun sama juga konsep, we remove oxygen dengan hydrogen. So salin je lah balik. Double bond maintain kan, straight terus pada nitrogen. Lepas tu nitrogen bonded to NH2. So hydrazine NH2 ni dia ada twice, tapi satu tu je means expanded. Okay, so again yang ini pun buang H2O, nitrogen is attached to NH2. Okay, so now we're going to look at for the phenylhydrazine. So dia beza dia dengan hydrazine before this is that dia ada N tu jadi NH, and attached to it we have our phenyl. Kalau benzene jadi substituent nama dia phenyl. So this is actually the structure. N tu memang dia ada 3 bond, memang tak ada satu hydrogen lagi. Dia memang N memang ada 3 bond je. Next we remove our water as usual, so we will get our product. Okay, so jangan lupa water tu is being removed, so terus directly bonded to N, which N bonded to another nitrogen. Nitrogen ni ada hydrogen attached to it, and to this nitrogen adanya kita punya benzene. Okay, so jangan lupalah make sure write down lagi sekali. So kalau question B, yang ini kira miss tak acil lah, tulis je lagi sekali. So maknanya we have our ketone kat sini. So nak cantik lagi, so N ni attached to double bond tu attached pada macam kita punya kaki ikan, ekor ikan. Okay, So next part we're going to look at for DNPH, which means for 2,4-dinitrile phenylhydrazine. So dia sama je macam question number 4 ni, tapi beza dia ada 2,4-dinitrile. Maknanya pada phenyl tu carbon number 2 and 4 ada NO2. So that's why lah 2,4. Kalau kamu kira memang pada carbon number 2 and 4. So what happened here sama juga as previous one. Okay, tapi yang beza dia substituent ni ada NO2 pada carbon number 2 and 4. We're still gonna remove our water. Okay, the same goes untuk yang question B ni. Okay, Miss buat je yang bulat tu nak remove water. And then we will write our NO2. Sebenarnya carbon number 2 nak buat kat atas ni boleh, kat bawah ni pun boleh. Carbon number contoh 1, 2 sini ataupun 1, 2 sini pun boleh juga. Sebab here still 4. Okay, so that's the last of your condensation reaction. Okay, so actually yang lebih sikit di NPH ni is actually it can use for your identification test. So kalau nama test dia, it is used, nama dia adalah Brady's test, which is used to detect the presence of C double bond O. Okay, so maknanya this test kalau kamu nak uji, contohnya nak differentiate alcohol dengan carbonyl, we can use this test. But then what is actually the observation? Okay, so let's look here. So this is actually the observation for Brady's test. So originally orange solution akan form yellow precipitate kalau ada C double bond O. So our observation is that yellow precipitate form. Okay, so that's the last of it of condensation. Tapi yang ini is a bit of introduction to the identification test for carbonyl. Okay, so I'm just going to continue with the identification test. So for carbonyl, dia banyak sikit identification test dia, and we have to look at one, which is our Brady's test, which help to detect the presence of C double bond O. Okay, second one kita akan tengok there are two different tests which can differentiate aldehyde dengan ketone. Again, what is aldehyde? Aldehyde mesti ada C double bond O hydrogen ni. Ketone yang both of our bodyguard tu must be a carbon. Okay, now let's look for the test, which is Tollens test. So this is actually the reagent itself. Okay, so how does it work is that kalau aldehyde dia bagi positive result, ketone tak bagi positive result. So maknanya aldehyde ni lah akan bagi result tu. So actually how does it work? Hydrogen ni akan undergo the reaction with the reagent and dia akan form jadi O minus. So yang ini lagi shortcut gila lah sebenarnya ni. So jadi O minus. Okay, lepas tu what happen is that for this reaction dia akan form precipitate from our reagent ni. So precipitate ni is actually our silver. So buat arrow ke bawah for silver. Okay, so walaupun arrow bawah ni sebenarnya untuk precipitate, tapi actually dalam case ni dia special case. It is a silver mirror form. Okay, so why do I mention so? So this is actually the result dia tau. So kalau contohnya batch lepas sempat lah buat eksperimen ni sama-sama dalam kelas. Okay, so what happen here, ini adalah aldehyde, kalau tu adalah original one. Kalau ni kau tak pandai buat, jadilah macam tu. So what happen is that silver mirror will form. So that is actually the product for our aldehyde. Okay, so itulah the result ni. Macam mana pula kalau dengan ketone? Kalau dengan ketone, again, what happen is that the hydrogen tu akan jadi O minus. Dia akan undergo reaction with the reagent. Since there is no hydrogen attached to our carbon double bond O, so there is no observable changes. So kalau observation pun boleh tulis no observable changes ataupun reaction remain unchanged. What does it mean here? Maknanya solution yang original tu tak ada apa-apa berubah lah. So dalam case ni dia adalah a clear solution. So dia maintain sahaja. So that is for your Tollen test. So let's look for your Schiff test. Schiff test ni tak perlu belajar reagent, just kena tahu observation je. Okay, so what is the observation dia? Okay, observation dia adalah so this is actually the result for Schiff test. Kalau positif, dia akan form a pink solution. So kita kata pink solution form for aldehyde. So kalau ketone masih lagi sama, no observable change ataupun reaction remain unchanged. So daripada original dia colorless solution. So now let's look for the test that can help us to differentiate aliphatic aldehyde from aromatic aldehyde and ketone. So what is mean by aliphatic aldehyde? Maknanya yang kita punya straight chain tu lah. Senang kita buat yang straight chain tu. Aldehyde kita attached to straight chain. aromatic aldehyde, our punya benzaldehyde lah. And ketone. So again, this is 2 of our aldehyde. This is aromatic aldehyde. This is yang aliphatic aldehyde. Any alkyl group attached to it. Okay, so this is again a ketone. So what is the test used to differentiate our aliphatic and aromatic aldehyde? Okay, so first adalah Fehling test. Fehlings tu dengan Benedict test ni sebenarnya sama je, cuma beza the name of the ion je. Dia Cu2 plus dengan OH minus. So what happen? Hydrogen sama juga dengan Tollen test. Hydrogen kita akan change to O minus and we're gonna form precipitate. So dah kali ni kita akan form, masa juga hydrogen tukar dengan O minus. Okay, for our copper tu akan form precipitate Cu2O. So arrow kena ke bawah. Okay, so what is the colour? Colour dia sebenarnya adalah brick red precipitate. So this is actually for a positive result. Okay, so kalau dia adalah aromatic, kalau dia adalah aromatic aldehyde, sama juga dia akan negative result. So dia adalah no observable change. So sama jugalah dengan observation. So Benedict test pun sama sahaja. So beza dia sebenarnya nama of ion tu je. Okay, so what I'm going to do, I'm going to copy paste all of it. Okay, so how about the observation? Ni sebenarnya observation dia. Jom kita tengok. So what happened here? Sebenarnya Fehling dengan Benedict ni is actually blue in colour. Okay, so this is actually the original solution. Kalau ada aldehyde, barulah kita akan form brick red precipitate. Yang ni macam orange tapi ya, boleh lah tu. Okay, so this is actually the observation for your Fehling and Benedict test. Okay, so now let's look for your iodoform test which help to present the methyl carbonyl group. So methyl carbonyl C double bond O ada CH3. Okay, so macam rasa familiar lah ni. Sebenarnya kita pernah belajar dalam alkohol, tapi yang ini dia macam complicated sikit yang ini Tapi kalau case of carbonyl ni simple je. So what I'm gonna do is that I'm gonna change yang CH3 bonded to carbonyl tu jadi O minus. Okay, previously kita tukar H jadi O minus kan. Iodoform test untuk methyl untuk carbonyl group. CH3 tu ya jadi O minus. So I'm just gonna redraw the structure. CH3 jadi O minus. How about the precipitate? Dia CHI3 arrow downwards. Okay, so this is actually the observation dia. Dia adalah yellow dia tu macam very soft yellow. So observation dia adalah yellow precipitate form. Okay, same goes untuk ketone here. Make sure kena pastikan ada methyl pada C double bond O. Since we have methyl here, so dia akan jadi C double bond O CH3. CH3 jadi O minus. Make sure ada precipitate. Okay, and then the observation is that yellow precipitate form. So for the test of carbonyl ni banyak sikit, tapi sebenarnya mostly dia sama sahaja function dia. Okay, again just for summary Brady test untuk identify presence of carbonyl group. Okay, so untuk semua aliphatic, aromatic aldehyde, ketone dia akan form yellow precipitate. So this is actually the reaction. Okay, kalau Tollen dengan Schiff to differentiate aldehyde from ketone, be it aliphatic ke aromatic ke tak kisah. Okay, so kalau untuk Tollen akan form silver mirror, untuk Schiff akan form pink. So this is actually your Tollen test. This one is your Schiff test. Okay, and then for Fehling dengan Benedict, it's actually differentiate aliphatic yang straight chain dengan aromatic and ketone. So for this both reaction, kita akan form brick red precipitate. And last but not least is iodoform test. Yang ini lain sikit to detect the presence of methyl carbonyl group. And we will form a yellow precipitate as well. So that's the last of it of our chapter 16.